Who remembers Mr. Canoe Head? Did you find a new home? Are you wondering why I stuck my head in there? Like, well, if it's good enough for your head, maybe it's good enough for me. So I expected this video to be building the box for the batteries, the one that's going to fit underneath the cockpit above the, what were they called? Stringers. I was not sure what those engine mounts were called. Anyways, problem I have is that I don't have enough space in my house. I have crap everywhere. I'm cleaning up, and it's going to take me a little bit longer to get that done. So I wasn't sure what to work on. I've been keeping an eye for some time for a outboard motor that had a good lower end that had a blown engine. And I found one for $100. I wanted something more 1980s, like early 80s, late 70s looking. This doesn't quite fit the bill. This has got more of a 90s look to it, but so be it. If this works, nothing's going to stop me from later on if I get access to a more era-appropriate one for the boat. Ooh. I found out. The term for 1980s futuristic aesthetic is a... Hello? Yes, how dare I? How dare I talk to the YouTubes? Huh? How dare I talk to the YouTubes and not you? What was I saying? Right, the 1980s futuristic aesthetic is apparently called Cassette Futurism, or also sometimes called cassette core. Anyways, I really happy to know that, because now I have a term to search for when I'm looking for inspiration. So in the meantime, I haven't actually done anything with this. It's in the box. I haven't cleaned it up. I have no idea what condition it's in, except that the seller told me the whole lower end was working. Apparently he rebuilt the engine, something went wrong, he blew the engine, and it sat in the shed for a long time, and he finally put it up for sale. I should say that the only time I have ever used an outboard in my life was when I was on the crossing with Reese. He wanted me to run into the dock to get ready to catch him, because he's got basically a full keel, so docking is a little bit hard. I found out that day that yes, I can use an outboard, but not very well. So to say that I am a beginner at all of this is politely understating things. Anyways, this was a 9.9 horsepower, which, as I understand, I'm getting dirty already. Oh, honey, I'm sorry. How dare I not pay attention to you? As I understand, a lot of 9.9s, they are downrated generally from like 15 because there's like taxes or something. I'm not quite sure. I'm not entirely sure how that works. But in any case, it should have enough space for what I want to do. So okay, that spins. I'm assuming I have to put it into gear somehow. I really have no clue how this works. Though I do know it sucks the water up. It's got a built-in pump, so water cooling is not going to be a problem. Obviously, I'm converting this thing to electric, or building it out as electric. I mean, it seems to spin free, and the propeller is in totally serviceable shape. I'll get a zoom in a minute. I mean, it's not perfect, but I don't care. I wanted something that suits the aesthetic of the boat, but doesn't look like a modern electric outboard. I want something that looks, I'm not going to fix this up. I'm going to leave it looking beat up. I might even intentionally make it look a bit worse. I want something that just completely is ignored when you're when you leave your dinghy behind. You are just one curious little kitty, huh? Can YouTube tell how much you've grown since the last video? So anyway, everything I can tell seems to be good. I have absolutely no clue how to... Oh! Okay, so it works. Spinning this works. Excellent. I have to degrease all of this. I'm not going to actually start work on this, but I figured I would pull it out, mount it, and explain the project, which will probably make this a relatively short video, which is very rare for me, but there you go. I guess that is the mid part. A little bit of corrosion there, but nothing too serious. I'm guessing that's going to need a gasket, or is that expected to get wet? Okay, well, anyways, hon, I don't want to bump your head. I don't even know what the make and model is. Obviously, it's Tohatsu. I don't see a model number anywhere. There must be a tag on this somewhere so I can figure out what parts to get. Well, there's a close-up of the interior. This is the old base I built for the Quattro back in the day. And I think it's going to be, I might have to move this out of the way, but I think this is going to be, oh God, I'm already getting covered in grease. What is this? Some sort of a rod? I see a bushing here. I have no clue what I'm doing. Oh, you know what? I think that might be connected to this. Forward, reverse, neutral. That's probably what those are. So I don't think I need those anymore. Some sort of a tube that goes, well, it looks like it goes there. Dude, I have no clue what I'm doing. But it looks like it kind of goes that way. Normally I would have taken more time to do research to figure out what I was doing. Oh, this is gonna fit just fine. But it was $100. I figured I couldn't go wrong for $100. I have spent $100 on stupider things. Okay, so there are threaded bolts, which still have threads. They're gonna obviously connect this and bring this up through the bottom. Okay, so while I'm figuring this out, let me explain to you what I plan to do. As you probably saw with my dinghy, now I'm going to get another dinghy at some point, but it's really small. I do not need such a big motor, not at all, for a dinghy. Honestly, a little, probably like 4 horsepower equivalent outboard would have been more than enough for my needs. But that's not why I'm doing this. That comes out, oh, that flips that way. Ah, there we go. That lets me bring this up. Okay, I see how this works. Funky. Okay. I plan to put a 5 kilowatt motor in here. Same controller, same motor as the 5 kilowatt efficiency motor I'm putting into the main boat. This should have more than enough space for me to mount the controller into here, mount the motor onto here, or maybe I'll build a whole mount so this can come off completely clear. I have no clue yet. But 5 kilowatt is enough to move the big boat, if I've done my math properly. The prop speed is going to be totally different than what's on the main boat, so the gearing is going to be different, but the controls will be exactly the same. This is going to have a complete duplicate of the 5 kilowatt efficiency motor. And I'm going to run it at obviously 48 volts, the same as the main boat. This means that I'm probably going to create a 100 amp hour, 51.2 volt battery that I can lift into the boat for when I need to run the thing, which should give me about 5 kilowatt hours of capacity. So range should be no problem. Getting up on a plane should be no problem. The real benefit though is I intend to have my dinghy be my get home motor. To borrow Brewpig's way of describing what they've done with their boat. I'm going to have a wire that comes off of the main bus bar that I can throw out the lazarette and over the starboard side quarter. And the reason for that is, I'll put a picture here of what it looks like, but you can push a sailboat with a dinghy if you have enough power. The way it works is you lash the dinghy to the aft quarter, and once it's lashed, you just push the boat with this. So the 5 kilowatt motor will give me the power I need to be able to push the boat. Not quickly, but at least push the boat. And by having the exact same architecture and motor in here, I can take that long lead, toss it over the side, and plug the battery from the main boat directly into the outboard. Now the outboard has access to the full 86 kilowatt hours that I'm going to put into this thing. So this is going to be a project I'm going to do over the winter. It's going to basically be a filler project until the boat's in the water, because obviously if I have the ability to work on whatever's needed to get the boat in the water, that gets the priority. But if weather or space, like I'm dealing with right now, is limiting me from being able to work on the main boat, this is the project I can keep falling back to. Let me set this aside now, and I've got to degrease this and clean this up. Literally, I just took this out of the box. Actually, I'm going to turn off the camera and go clean my hands. I'll be right back. I have been going back and forth and back and forth and back and forth on whether I was going to go with 6 batteries or try to stick all 7 batteries in. I have decided that I'm going to go with just the 6. And the last battery, the one that I originally built, is going to be broken up into 12-volt batteries. It's this battery, the original one that I'm currently using to test the motors, that I used for the 12-volt batteries on the trip home last year, a year and a half ago. God, time is going quickly. Anyways, with that decision made, I spent a fair bit of time taking measurements on the boat. The distance from the bulkhead to there is about 33 centimeters. Let's say I have back here 80-ish centimeters to work with, give or take. Starting from the jet I was talking to called these sleepers. So I'm going to call them sleepers. To the diesel bulkhead is about 108 centimeters. Say 138 centimeters from the bulkhead to just aft of the hatch. From the aft of the hatch to the start of the prop tube is, let's say, 53 centimeters to call it tight. That means that I've got 85 centimeters from that bulkhead to the start of the prop shaft. From the bottom of the cockpit to the top of the sleeper is 60 centimeters. These are not fine measurements, but if I was to guess, it's about 40 centimeters to fit within that. I need to keep access to this and the shaft log open in case I ever have a problem with the shaft log. I need to be able to tighten it up very quickly. So I kind of have to not have any batteries here. I did a drafting course way back in the day on paper. This is back in the 90s. I learned a little bit about drafting, extremely basics, but you can see page after page after page I've got here. I was sitting down and trying to figure out how I could build the most space efficient but strong battery box that would fit within the confines of the battery bay. Please forgive me for my terrible drawing. Let me see if I can zoom in a bit more. From the top of the sleepers, which is where the engine was mounted onto, those two rails, from the top of the sleepers to the bottom of the cockpit, this distance here was 60 centimeters. So the maximum height of the box was 60 centimeters. Now keep in mind, when I say that this is the space, I cannot bring this box completed into the boat. I have to bring it in panels and assemble it in situ, meaning I have to have enough height clearance to be able to lift the lid over, drop it in, and get the tools in to tighten up the bolts. So though it's 60 centimeters, it's not really. So that set my vertical height limit on the box. So going from the center line with the prop tube, this is the diesel tank and the diesel tank bulkhead. At the back, where it pinches in the most, it's 80 centimeters from the top of the sleepers, they're sleepers, to where it would bump into the hull was about 80 centimeters wide. So that set my port to starboard maximum distance. The last measurement to figure out was how long could the box be. Where the opening of the prop tube is, without the shaft log, is 53 centimeters, forward 85 centimeters, backwards, astern. Ideally, the length of the box would be such that it minimally blocked access to the prop shaft tube. And the reason for this is, every boat should come with a nice water feature. Where is it? There it is. That's totally normal. No problem at all. When I was preparing for the trip home, I had a massive leak here. A leak that could have cost me the boat. So the idea of blocking access to the shaft log and the stuffing box is just a non-starter. It can't happen. I could come over it a little bit so long as I could get my hands under it, and there's a very, very large gap, vertical gap between the hull and the bottom of this, or the top of the sleepers, so I could come out past it a little bit, but realistically anything more than 85 centimeters long, and I would start to make my access here difficult. In an ideal world, I would keep the box length 85 centimeters or as close to 85 centimeters as possible. So with that, I had the upper limit on the box of 60 centimeters tall by 80 centimeters wide by 85, give or take, centimeters long, fore to aft. So folks who remember back in the early days, I spent a lot of time pontificating over how I was going to align the cells. I had something called the gum stick which was going to be all in a series that was very long with staggered cells so I could get the positive and negative terminals close to the front. I tried 8 back, 8 forward, etc., etc., etc. And I ended up settling on what I've always called the snake design, which is what I have here. That is where you have the main pack negative, cells oriented like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 main pack positive. It kept the packs relatively damn tight. It meant that I could use the same length flexible bus bars on all of the connections, and it put the negative and positive at opposite corners. Knowing that this has been my preferred design for a while, I wanted to see if I could make this design work. If I couldn't, I would have gone back and tried different configurations, but I think I've got it working. So in an ideal setup, I wanted to have this times 6. In an ideal world, all 6 would be on the same plane, meaning I could take the lid off and immediately gain access to the tops of all the cells of all 6 packs. Very quickly, I realized that was not going to happen, because if I looked at this cell arrangement, the length from the back of the cell to the front of the cell is about 704 millimeters, about 71 centimeters, give or take. And this isn't using the measurements coming from the spec sheets. This was from me measuring my actual cells, which are now a couple years old, and so have some bloating on them. And it's the size that you're realistically going to use rather than the spec sheet size. So I trust these numbers. With the height being, where was the height? So the height of each individual cell was 230 millimeters, 23 centimeters, but really I had to assume 25 to give myself working space for the flexible bus bars and the bolts and whatnot. So for each pack, I'm now looking at, say, 71, give or take, by 25 by, the width was about 31 for the raw cells. With that, there was no way I could put all 6 side by side in the engine bay. I had to stack them. So I started coming up with a design that would give me a stack of 3 across in 2 rows. And 250 plus 250 would give me 500, so 50 centimeters, which that's 50 of my 60 centimeters eaten right there. Then I had to figure out about all of the actual wood I was going to use, and I will be using wood. Let me talk about that more in a second. The wood I'm going to use to actually support all of these cells. This is going to be about 1,000 pounds, 1,000 to 1,200 pounds when it's all said and done. This can't be flexible wood. This can't be weak wood. So if I had a 16 millimeter bottom panel, a 16 millimeter dividing panel, and a 10 millimeter cap, and the 4 sides and the dividers inside were also all 10 millimeters, it meant that now I was looking at 542, so 542 millimeters out of my 600. It's going to leave me about 7.5 centimeters or about 3 inches between the top of the box and the bottom of the cockpit. That's good. Width-wise, I was looking at 80 centimeters width-wise, which is my upper limit, but it fits. Because remember, that upper limit is at the very, very back. As soon as I start to come forward, the hull widens out and I have space to work with. I need to explain how I plan to actually orient these in the boat. So where the lazarette hatch is, I want to be able to climb into the lazarette, and where that would normally leave me facing the port side of the boat with the engine in front of me, I want that to be the face of the batteries. That's going to be where the wires are going to come out for the 6 packs. And I want to have a panel that I can remove to access the BMSs and the T-class fuses that are going to be in there. So when I take that panel off, you're going to have a gap. You'll have access to this hatch. It's really not well drawn. I'll show it better in the 3D in a minute. But there'll be a little bit of a cavity where the BMSs will be in, etc. And then the rest of the battery goes the distance. So remember the access panel from the quarter berth? That's effectively going to be useless now because that would open up into the back of the battery. So again, sitting in the lazarette, facing the port side, I would have 3 batteries along the bottom. So battery, battery, battery. Second row, battery, battery, battery. How the hell am I going to install this? So the current plan is I would bring the panels in. The 16 millimeter base panel is going to give me enough space that I can recess it out and drop bolts into the stringers that used to mount the engine to help keep it from the base plate from moving around. That will not be the only way that the battery box is secured. It's just an additional way. I need to make sure that I sink the bolts enough that they never have an opportunity to come up and touch the bottom of the batteries. Then I will install the bottom 3 packs, one cell at a time. There's no physical way I can bring these batteries in completed. And I knew that, and it was actually one of the reasons why I wanted to buy raw cells. It gives me the absolute highest energy density I can possibly get away with. And there's going to be vertical dividers, 2 vertical dividers between the 3 cells. And those will then act as supports for a center shelf that goes in. And there's going to be a rebate along the 3 walls that slides into. Put 2 more dividers in that go up to the top, and then I can insert the other 3 batteries on top of it, wire them up, and then have the top lid go in and drop down, and it'll be fastened from the sides, not from the top. Then I can close everything up, and it should all fit, hopefully. I am going to make the first box out of plywood, so that if it screws up, it's far less painful and expensive. Assuming I can get the box into the boat and bolt it down, then I'm going to start to build the final box, which I'm going to build out of white oak. White oak, here's a picture of when I built the plinth for the head. Remember, I switched out the flushing head and the black water tank for a desiccating head. The desiccating head is a much wider base, and there's a little step in my boat where the old head used to bolt down to. Obviously, the new head was just going to fall off of that. That is a 10mm thick piece of white oak, and it easily held our weight when we were using it, and it's just free hanging probably 2/3 of the length out, and I can put all my weight on it and it barely flexes. It's extremely strong. Going to 16mm for the base and the midsection, which is going to bear the weight, this box is going to be stronger than any plastic box that's out there that any batteries would be in. I have no concern about this. And also, I'm not going to be gluing any of the sides in. They will be sealed tight to minimize water ingress, but I'm going to set up a exhaust so that if any of the batteries ever vent, this is part of ABYC compliance, the gases from a venting battery can be vented out. Remember the 2 little exhaust ports right behind the cockpit seat. There's 2 3-inch circular vents. What do you call those? The cowlings? Whatever. One's for drawing air in, one's for blowing air out. I'm going to repurpose so that there's 2 outs. One will be for cooling the engine, one will be for cooling the battery. I don't expect the battery to ever get very hot, but again, it has to be vented for ABYC compliance. So it's not going to be watertight. Honestly, if I get water to that level in the engine bay, I'm not worried about the batteries anymore. When it comes time to build the final box, the bottom plate of the box is actually going to go out forward quite a ways past the forward wall. And the reason is that's going to get a slot cut out of it to give access to the prop shaft and support a 15-degree angled face where the electric motors are going to be bolted to, and is going to also act as the thrust bearing, or the thrust bearings go onto the prop shaft. It's where the thrust bearings will connect to the boat. So the weight of the batteries and that whole box assembly, so securely connected to the boat, is going to be what transfers the power from the propeller through the thrust bearings into the frame to push the boat forward. You know, I'm really torn here. Part of me doesn't want to release this video because I feel like it's incredibly boring. The fact that you're hearing me say this means that you actually stayed and watched until this part, so thank you. Is it better to release fewer videos where it's more building, or release more videos where I talk about the planning and the work that goes in between the builds? So that was talking about the box. The other thing I've been working on behind the scenes that I haven't really shown you guys yet is I'm working on the logic for the helm. I'll go into this a lot more detail when I get onto this part of the video. This is talking about 3 future videos. There we go. If you recall, when I last spun the motors, I was having a lot of problems and I couldn't diagnose it because the wires were all over the place. So to make debugging the motor easier, I started breaking up the logic into different prototyping boards, and then I started making proper cables for all of them. I'm going through and I'm putting labels on all the cables. I'm labeling all of the boards and what they do. So for example, there's the DAC board. I'm trying to get things ready so that when I get back to debugging, I'm not fighting my wiring installation and I can actually focus on solving code issues. If you recall, when I tried to spin up the motor and spin down the motor, there was huge lag, and It spun in that it worked, but clearly it had serious issues. I have not powered up any of these boards yet. In fact, the throttle indicator board, which I haven't even talked about yet, I haven't even finished soldering the back yet. At some point in the near future, I'm going to get back to working on this because I need to get these motors underway because I have to start designing the mounts and where everything's going to go. And there's no point doing that until I know that the go bits make it go and the stop bits make it stop. That's just a big catch up on 3 different parts of the project that I've been working on behind the scenes. So yeah, I'm the Digital Mermaid. This has been an update on these 3 projects. I hope the next video is me building this really big box. It's going to be fun to put 86 kilowatt hours into the smallest physical box I can possibly make. Okay, toodles. She's growing fast. Yeah. They're so cute.